Hello everyone, welcome to day 2 of second trimester. Today we're going to be looking at lesson 1.2, measuring and constructing segments, and that is on page 14, page 12 in your textbook. If you want to follow along kind of in your textbook as I go through this slideshow, that would be totally fine. Again, we'll start on page 12. If you want to have a notebook and pencil ready, that would probably be helpful because we'll look at some examples. When we go through these examples, I'll have you pause, try it out, and then press play once you are ready to see the answer. If you get stuck or if you want to check your answer, that is the way that we'd like to do that. So yesterday with lesson 1.1, you watched a video, and really that video covered terms, right? Lesson 1.1 went through a bunch of terms like point, line, plane, line segment, endpoints, ray, opposite rays, all kinds of stuff like that, just so that we could have a foundation going into the rest of this stuff, right? When I talk about a point, if I talk about a line segment or a plane, you guys should know what that means because you went through and worked through those definitions. I know that can be a little bit of a, for lack of a better word, maybe a boring lesson because it's a lot of terms. There's not a lot of application, but again, that's the base that we need for what we're going to be talking about today and really throughout this trimester. So today we're going to dive into a little bit more application. We'll talk a little bit, like the title of this lesson is, we'll talk a little bit about measuring, and then how we construct and how we talk about line segments. So let's dive in. Our success criteria for this lesson. The first one, I can explain the difference between the symbols for distance and the symbols for a segment. Okay, so really the two different things, distance and segments. I can use a ruler to find the length of a segment. I think that's something you guys can probably already do, is that if there's a line on a page, you can hold a ruler up to it and you can say, hey, that line is 3.5 inches long, or that line is 6 1/4 of an inch long. But we're going to talk about that a little bit today. I can compare segments for congruence. So that's talking about we can look at two different segments and say, hey, are these congruent? Are these equal or not? I can explain the segment addition postulate and can use this postulate to find distance. So you probably haven't heard of the segment addition postulate. It's not as complicated as it sounds, and we will talk about that towards the end. And then lastly, I can apply that segment addition postulate to solve two real-world problems, All right, so you heard that word postulate in the success criteria, and you're probably thinking, what is a postulate? I haven't heard of that before. Well, a postulate, or we would also call it an axiom, is something that just is a rule that is accepted without proof. So a lot of times in geometry, and hopefully this trimester, we'll look at proving some things, proving theorems. So something that has proof, we call a theorem, but something that we just accept as truth without proof would be a postulate or an axiom. And we have to have postulates and axioms in math because it's not possible to prove everything. Postulates and axioms are things that we know are true, but we can't prove it, so we just say that we assume that they are true, or everyone assumes that they are true. These postulates and axioms are the base for theorems. So theorems we can prove. We use postulates and axioms to do that. So postulate 1.1, we just call it the ruler postulate, and that has two key terms that go along with it. The first one right up here is a coordinate. So you guys know what a coordinate is. You guys are pretty familiar with that, but the official definition that we use for geometry is that the points on a line can be matched 1-to-1 with real numbers. So we have a point on a line here, we're matching it with the number x1, we're saying we're matching it with 1. Point here, matching it with 2. The real number that corresponds to a point is the coordinate. Okay? So here, point here, number that corresponds with it, 1. Point here corresponds with it, 2. No big deal. Those are the coordinates of the point. The x1, x2 are just to make it a little more complicated because that's how we like to do things in math. Well, I shouldn't totally say that. The x1, x2 makes us so that we know that from this, that 1 isn't talking about distance. The x1 means that we're talking about the point, not that that's at 1 inch, or that this one is at 2 inches. Distance. Well, let's backtrack. One more thing about coordinates. If we were to talk about here to here and talk about this line, we would say that this is line AB. We would put a line over top of AB. Right? That's what you talked about in lesson 1.1. That's how you know we're talking about a line. Now, when it comes to distance, that label, how the symbol we use to talk about distance is a little bit different. The distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. So first thing, when we talk about the distance between 2 points, the distance between A and B, we use A, capital B, but we do not put a line on it. We don't put a squiggly over it. We don't put dots all around it or whatever you might do. All we do is use capital A and B. So there's the difference between the symbols we use right there. Distance, capital A, capital B, coordinate, or a line, or a line segment, capital A, capital B with a line over it. So that's what the first part talks about, how we write distance. The second part gives kind of the formula that we use. So AB, the distance between point A and point B, equals the absolute value of x2 minus the absolute value of x2 minus x1. Okay, so let's, just for example, let's say that x1 was at 2. Let's say that x2 was at 5. So if we take AB, we know that equals the absolute value of, over here, x2, 5 minus the absolute minus 2. 5 minus 2 gives us 3. Absolute value of 3 is 3. Now, what if you said, hey, Mr. Lehman, I did put the 2 first and put the 5 second? Well, we would still be okay because of those absolute value signs. So 2 minus 5 would give us -3. The absolute value of -3 is still 3. So the distance, no matter what order you put it in, the distance between A and B is 3. Now I mentioned, and in the bottom of page 12, you can see there's the picture of the ruler and everything like that with the ruler postulate. We're not going to talk about that much more. The main thing that we want to know from the ruler postulate is distance, and that distance formula that we had. That the distance between A and B equals the absolute value of x2 minus x1. And you could, if you had 2 points or a line segment on a piece of paper and they were labeled, you could use the distance formula to find the distance, or you could take out a ruler and find the distance. They could kind of check each other on that. But we're going to stick 99.999% of the time, we're going to use the distance formula, and we're not going to break out the rulers at this point. So looking at the top of page 13, a construction is a geometric drawing, right? A geometric drawing just would be exactly what we think of with shapes or angles, right? A geometric drawing that uses a limited set of tools. Usually those tools are a compass and a straight edge. So if I were to want to make the perfect triangle or the perfect circle, then I would want to use a straight edge to make the perfect triangle, to make my line straight. If I were to try to make the perfect circle, I'd want to use a compass because I could put that middle down and keep my hand steady and draw a perfect circle. So that's all that it wants you to know about constructions. That's all that we're trying to point out, that if we were to use tools and practice some constructions, you would just use a compass and a straight edge. Now let's talk about congruent segments. a little bit. We talked in our success criteria about congruent segments, so let's dive into it a little bit more. Line segments that have the same length are called congruent segments. That should not be a shocking statement. We should see that. Line segments that have the same length are called congruent segments. And how we represent the word congruent is right here, the equal sign with the squiggly line on top. Another word for congruent, when we see the word congruent, we really should think equal, right? AB is equal to CD. They both have a length of 5. But in geometry, oftentimes, we use the word congruent because we're talking about shapes that are congruent. We don't say shapes are equal. We say shapes are congruent. We don't say lines are necessarily always equal. We say that they are congruent. So you'll hear me, and in our textbook, we'll use this symbol and see the symbol, and that just is talking about two things that are congruent. So let's see a couple of examples using the distance formula and using the idea of congruence. So first, the directions say plot a couple points. So plot, first we have, well, I'll put my tick marks in. First, plot point J, which is at -3, 4. And then K, which is at 2, 4. Then we also need to plot L, which is at 1, 3. And M, which is at 1, -2. And we are looking to see, and I'm having a hard time choosing a color. We haven't used green. We are looking to see if these points are congruent. So how we do that, oh, I forgot to label. I'll add it to my favorites now. Cool. I forgot to label these, so I will do that. All right. So if we're finding the distance, remember our distance formula is the absolute value of x2 minus x1. Now don't let this deceive you. It could also be talking about y2 minus y1, and we'll look at that in a second. If we're looking at just J, this is a horizontal line, so we'll want to be looking at our x coordinates. So JK equals the absolute value of -3 minus 2. -3 minus 2 gives us -5. Absolute value of 5 gives us 5. So that is the distance between point J and point K. Now let's look at the distance between L and M. Remember, when we're talking about distance, just the capital L, capital M. Now, in this case, we have a vertical line. So we're going to be looking at the y values, right? Because this distance is shown by the tick marks on the y axis. So we have 3 minus -2, which would give us +5, and would equal 5. So since they both had a distance of 5, we would say JK is congruent to LM. Pretty straightforward there. If they were to have different distances, like say somehow this was extended, this came out to be 6, then we would say they're not congruent. We would just say JK is not congruent to LM. But since they have the same distance, the line segments are the same distance, we say that they are congruent. All right, let's look at another postulate. So postulate 1.2, now we are moving over to page 14, right at the top. Postulate 1.2 says if B is between AC, so if B is between AC, then AB plus BC has to equal AC. Pretty straightforward, right? if AB, if AB plus BC equals AC, then B is between A and C. Right, those are two different sentences that are really saying the same exact thing. Right? If we know that this section plus this section equals the whole thing, then that means there has to be some point in the middle, right? In the middle of these 2 points. That's all that we're getting at here with the segment addition postulate. Segment, right? Maybe not maybe, but for sure, AB is a segment, BC is a segment. If we add them together, then we will get from A to C. That's all that the segment addition postulate says. And I think when we look at an example here, it will become even clearer. Find DF. So we want to find from here to here would be DF, this whole line. So this would be where you pause the video, find DF, and then hit play once you're ready to check your answer. All right, welcome back. If we're finding DF, we see that DE is 23. We see that EF is 35. 3 plus 5. So we should have found that the distance of DF is 58. Example 3. Find GH. So this time we have a little bit different information. This time they give us the whole thing. They give us a part, but we want to find GH. So why don't, again, you go ahead and pause. Try to set something up so that you can solve and find that X, that missing part, GH, and then come back and check your answer. All right, so the way that I look at this one is I know that the total is 36. I know that I have a 21, part of it is 21, and if I do 21 plus X plus whatever this is, I have to get 36. Just like here, it says that if we have AB plus BC, we have to get the total. I'm using that same idea. We have FG, we need GH, and we know that from F to H, we'll get 36. So all we need to do is solve for X. That cancels out. X would give us 15. So we would say the distance of GH equals 15. Okay. Again, you don't have to put X here, or you don't have to put anything there. That just, I think, is a good way to think to remember that you know something has to go there. There has to be a distance here. So I just put X in to fill that spot, and it makes it easy to set up our equation then. All right, last problem, monitoring progress. Bottom of page 15. I will say, before we dive into it, this question is very similar to one that we have on a test, where we have a map, we have a couple cities, and we want to find the distance between two cities. So if you get this one, then you are getting what you need to from this lesson to be successful on the test. So go ahead, pause the video, and when you're ready to check it, come back. All right, let's take a look. For this one, we want to find the distance from Albuquerque, New Mexico to Provo, Utah. So we want to find this distance right here. We see that the total is 680 miles. The part of it that we already have from Albuquerque to Carlsbad, maybe that's how you say it, is 231. So we know that 231 plus our X will give us the total. So all we need to do is subtract 231 from both sides. To get that X equals 449. So that would mean from Albuquerque to New Mexico, from Albuquerque to Albuquerque, New Mexico to Provo, Utah would be 449 miles. Like I said, if you nailed that one, then I would say that you understood what we talked about in this lesson and that you should be in good shape moving forward. If you didn't, then this might be a good time to go back and watch a part where it got a little bit fuzzy, or to ask a question of someone that's around, or send me an email, or check out those extra resources that I have at the bottom of our agenda today. So let's really quick, before we're done, take a look at our success criteria. First thing, I can explain the difference between the symbols for distance and the symbol for segment. So the symbol for distance, if we have a line segment here, A and B, the symbol for distance, would just be AB. The symbol for the actual segment would be AB with a line over it, with the segment over it. Second one, I can use the ruler to find the length of the segment. That's one that I hope that you could do already. That's just if you have a segment on a piece of paper, you can hold a ruler up to it and you can tell how long that segment is. I think we should be able to do that. I can compare segments for congruence. So that was, where did it go? Oh, here it is. That was what we did right here. We looked at these two segments, JK and LM. We said they both were equal to 5, so we compared them, said, hey, those two things are congruent. I can explain the segment addition postulate and use the postulate to find distance. That's what we ended with, right? Remember, the segment addition postulate just says that, hey, if we take from here to here and add it from here to here, then we will get A to C. And I've got all kinds of circles and colors going on here, so that might be a little bit confusing, but it's just saying that if we add two segments, then we will get the total segment, really. Lastly, I can apply the segment addition postulate to real-world problems. So right here, real-world problem. I need to know how far it is from Albuquerque to Provo, but I only know how far it is from Carlsbad to Albuquerque, and I know what the total is from Carlsbad to Provo. You know, maybe when they made the textbook, they didn't have Google Maps or Apple Maps, but maybe you'll be out of service and you have to use a real map. And you'll need to know that distance. So that is how we could do that. All right. Thank you for hanging in there. Hopefully today was a little bit more engaging than yesterday. And if you have any questions, check out those additional resources, shoot me an email, and we can get those